sleeping right now. Yes, that's why if you look we are the teacher all the time. Lecture always keep before lunch. Otherwise, teacher has no more to teach the students, and the students have also no more to go for the classes. Unfortunately, we got this lecture after 5 o'clock. Just 5:30 we got. It should be in the morning session. But anyway, that is a time restraint and certain circumstances it comes. Madam Nilima already discussed lots of heterocyclic chemistry, especially she discussed about the nitrogen phosphorus containing heterocyclic chemistry, and she discussed lots of reaction mechanism and calculations, but I will not bore you again because the topic again assigned for me is a heterocyclic chemistry and characterization. That's why I don't want to bore you again with the heterocyclic chemistry. I will go a little bit different way. If you look, these are the certain molecules I am going to show here. That is all synthesized in my laboratory. And all these molecules, if you look, they have a heterocycle somewhere. Any molecule you can take, you will find a heterocyclic containing 1 or 2 or 3 heteroatoms in the cyclic ring. That's why it is called heterocyclic. Otherwise, I am not talking cyclohexane type of ring. We are talking heterocyclic molecules. And these all are somewhere natural products associated molecules. Means one or other form is present in the nature itself. Means these are different products. During, I am just putting this one for last 3 years my research in these slides, and if you look, these molecules all have at least more than 25 different compounds, and each whatever shown here, that is one paper. I will discuss some of these papers here. First paper, if you look here, we are talking design and anti-proliferative activity against some conjugates. We are talking natural products like flavone and flavone conjugates with tanaproject. Tanaproject is a prostate cancer drug, and that widely we are going to hook with another natural products to get enhanced anti-proliferative activity, especially we are looking anti-cancerous property. Look here. These are the design, how we have designed the molecule, because if you look these molecules, you can go for aldol condensation reaction too. But I am not following the aldol condensation here. Glycine condensation you are studying in the textbook. That is not followed here because that chemistry is not working. We have to follow some other chemistry, and that's why we are going to get some other type of derivative here. This is oxo, flavone containing compounds. Our aim is to put a chain. If you look here, I am showing 1, 2, 3, 4 carbon chain at 3 positions. That is our aim, to bring the chain in the molecules, and that will increase the lipophilicity of the molecule. That's why they can interact with the proteins, interact with the receptors of the, especially we are going to discuss the breast cancer, where they can interact with the receptor with the help of hydrophilic chains we have put here. Same time you are looking iodine 25, 125. What is the iodine atomic weight? Iodine atomic weight number. What is normal iodine? Many chemistry students is here. No. It is 127. Yes, iodine is 127. Means I am putting here 125. That is a radioiodine I am putting here. Means we are putting for the imaging of the breast cancer, how they are going to be imaged inside the cells, and that is done with the help of Sept or PET technology. That is, I labeled this one with the help of BARC, Bhava Atomic Research Institute. We label this molecule with 124, 5. And if you look at chemistry a little bit, I am giving here flavor. It is not going directly with the Claisen-Schmidt reaction. That's why you are following a different path to bring the change in the end. And because Claisen only work for one carbon. After ketone, there should be one or hardly two carbons. If you are going to increase the chain of the carbonyl chain, it will not work. Chemistry is failed to work in that case. That's why, if you look at the basis in the optimization reaction, we are doing so many trials to get the right product. In this one, we are trying different conditions, different base, but we are not getting according to aldol condensation. Finally, we got a new condition, that is, you are getting 95% yield with the help of this. This is not based on Claisen condensation. Same way, we are looking different derivative for the formation of flavone. Iodine leveling, again we have to bring the iodine. That is not again easy. We have to break the bromine into the tin derivative. That tin derivative is finally quenched with two different type of iodine. One is normal iodine to get the cold product, that is called cold iodine product, and other is radioiodine level, that is a radio product. And that radio product is going to be used as a breast cancer. Characterization, if you look at characterization, we generally go for the NMR. NMR is the first technology, and techniques to characterize the compound here. Bruker's, that is going to be used in 500 megahertz machine here. And if you look the 500 megahertz machine, it is not going to resolve the spectrum. That's why the bottom line spectra is further expanded in the top spectra to know the exact whether spectra is a first order spectra or second order spectra. And that basis, if you look, each peak is enlarged in hertz to find out what is the nature, how they are going to be formed or not. This is the NMR, proton NMR, you are studying. Similarly, carbon-13 NMR. Carbon-13, this is the conformation of your product. Yes, it is formed. In the same way, high resolution mass spectroscopy, if you are talking, you are taking the malt, you are getting a single bond peak. There is no other impurity in the product. You are getting the molecular ion peak of the molecule. If you are going to as a flavone, same derivative, what is changed? You are going to change with the nitrogen. Instead of oxygen, we are talking as a flavone. And in this derivative, look, we are going to do some same type of chemistry for order synthesize or optimize the reaction condition. And again, we are going to level with the radioactive isotopes as well as cold chemistry here. And you are getting some biology. If you are looking, IC50 is reported here. This is right now in communication, this paper. MCF7, that is a breast cancer cell line we have used, and we are getting this value for the activity. MDA, that is another, these are two progesterone receptor positive negative cell lines we are talking here, and we are getting different value for these compounds. Characterization, if you look at the characterization again, we have characterized on the basis of NMR, proton NMR, carbon-13 NMR, and high resolution mass spectroscopy. You are getting these things. These are all, if you look at different derivatives, you will get different products in the same fashion. These are the radioactive, nitro, again nitro compounds, we are going for the biology. IC50 we have calculated in the case of this one. And similarly, we got the image from the molecular imaging division of the bark, and here I have not put the image of that ID25 level compound. But anyway, this is the again characterization related with this derivative. These all are one class of compound having flavone and as a flavone compound. Here we are looking different chemistry. Tandem project, this moiety, look one moiety we are putting at the heterocyclic where they contains one nitrogen, one oxygen, and that is right now in the market. That is you are using for prostate cancer drugs. Now we are going to break that molecule and hook with the natural products. And with different chain, N value we have given and different, you say the activity, it is shown here, compound 42, 41, we are getting some activity related with the anti-proliferative action of this molecule. Again, characterization is not easy. All spectra is second order spectra, and that's why you need higher resolution. And above, we are going to show again it as carbon 13 here. Mass. This is another that same topics we have put directly in the chain here. Instead of going to give a flexibility by increasing the chain length, directly that molecule, Tandem project is hooked with the these two derivatives, and in that case, you look the different screening of derivatives. We have at least we have synthesized 35 derivatives here, and out of this, you look the three which is used right now for the drugs as a drugs FU 5-FU that is used as a prostate cancer drug. And look the activity in different cell lines. That is showing the bold whatever we have shown here. That is looking better activity or better activity as compared to the marketed drugs, which is given in the bottom three. FU is given here. In different, these are different. That is a cervical cancer. That is a you are talking a breast two line. One is another cancer line, and you look the characterization. We are increasing the side chain to make it lipophilicity because these molecules are less soluble in organic solvents, and that's why this spectra. If you look, this is not good because this spectra is recorded DMSO. That is not looking good. High DMSO peak is coming. Here, broad peak is coming, and spectra is something, carbon 13 is looking here, so we'll get. But HRMS is talking, means this compound is pure, you are getting single peak related with this compound. And so, you are getting the NMR, mass, NMR, all are going to explain your compounds. Carbon 13. You are getting mass again, you are getting. This one is another derivative we are looking for. Again, same study, and we are looking this with the help of Prince cyclization. Through Prince cyclization, this is a 6-member oxygen containing heterocycle we are talking. This is heterocycle. It is going to be derivatized in another paper we have published in the European Journal of Chemistry right now. That is, we are looking, instead of tosylate, that ring is converted into a side molecule, and that we are going to click chemistry, and click chemistry we are going for synthesizing another derivatives. And if look, we have already synthesized 30-40 derivatives. Out of this, 3G and 4G is giving good activity against the cancer cell lines, and XRD is also talking this one. Again, this chemistry, that is a well-known click chemistry, but To get the better result, we have optimized different bases and catalysts. According to that one, we are getting different products here. Characterization, if you are looking, all are well characterized with the help of proton NMR here, carbon 13 NMR. If you look the, I generally assign the number where which carbon is going to be appeared. This is another work here. Our own derivative we are looking, and that is published right now in Tetrahedron later, and we are looking some more diastromers of this product right now to get the derivatization, further derivatives of this compound. If you look at all these assigned numbers, it is going to talk about different position of your different protons and so on, carbon 13. This is another, we are looking for another derivatives looking tricyclic in a linear fashion, and we are looking 2 nitrogen containing and oxygen nitrogen containing. Further, we are going to expand the cyano and amino containing compounds in the right side. Similarly, here we are going to expand the chemistry of these products and characterization. If you look, all are well characterized. You are getting the NMR, carbon 30, carbon 30, carbon 30. This is another chemistry again based on, if you look, this is, we are looking a big molecule for the anti-proliferative activity, hooking a chain of heterocycles. 1, 2, 3, 3 heterocycles we are going to hook in this molecule to get the title compound. It is given name is used, that's why you can get. That is also characterized with the help of NMR. That is characterized with carbon 30. All are assigned. The fix is given for different number. This is published in 2013. Another type of coumarin based molecule. If you look the spectra, that is 2 oxygen containing heterocycles we have synthesized, and reactions mechanism I am not going to talk here. Characterization, if you look, all products they are going to be well characterized in the different spectra. Carbon 30. This is another, if you look, this is another derivative. We have 3 heteroatoms in the same molecule, that is published in Heterocyclic Japan 2012, and we are looking continuous simultaneous oxygen nitrogen and nitrogen nitrogen containing heterocycle 7-member rings we are talking here, and that is chemistry is well worked, and we assigned here, I didn't put the spectra, actually it is expanding lots of slides, but if you look, that is well characterized again. NMR is working. Similarly, this we have put simultaneous 3 rings containing nitrogen, nitrogen, 5, different pattern. If you are going to talk about the heterocycle, that pattern is going to define their activity. And 1 heterocycle, 2 nitrogen containing, 3 heterocycles in 5, 6 ring formation. We are looking these molecules, that is also well characterized, and that is reported in different ways. That is another, if you look here, heterocycle, that is also published in 2012. Different based on coumarin with the amino groups on the coumarin molecule. We have hooked 3-component, 1 reaction system, 1 part, 3-component reaction to get the a big, or you can say 2 consecutive nitrogen, oxygen, 6-member ring, and you are getting these products. That is we have characterized with this process, and this is carbon 30. We are looking here. Finally, thanks to my students who work hard.
When they are using as a anti-cancer or drugs, whether they are compatible with the cells or what?
Yeah, it's what problem is. Next generation we have to, because these all are PhD students are working. Once they publish 5-6 paper, they are in hurry to get the degree and go for abroad. That's why if you are going to give another students for the work in the same field to elaborate the work, they don't like, because they are the chemistry student. Biology, for biology you need a biology collaboration. So that they can take the molecule, they try in different way. They go for the application for different parts. Okay? That is the problem. Otherwise, we have tested some key leads we have detected. This molecule is working. We have 45 key molecule detected. 5 is working, suppose. We have to focus on these 5 derivatives. That is not still done. And for that we need a collaboration. Somewhere biology people, some will good in these activities, those who are involved.
Have you checked the in vivo also?
Yes.
In vitro?
Yes.
In vivo also. So maybe very good candidate for that.
Yes.
Some questions from your minds. I really looking forward to hear you. Anyone? Don't hesitate to ask. Because
Yes,
Professor
at
Naseem
least NMR you are studying in the classes. Proton NMR, you see, we have a not a first order spectra. What is the second order spectra? You can ask at least. All are giving the second order spectra.
No? Anyone?
Yes.
Yeah, thank you so much, sir, for your nice presentation. My question is that in your talk you told about the interaction of your compound with a protein. So, and you talk about NMR also. So, some data include it is showing that the protein NMR also, some protein NMR and the effect of
that is a duty of biologists, biochemists to look at. That is a study we are need a collaboration. That things we are looking for biotechnology with people.
Yeah, that compatibility issue must be done by some biotechnology.
Thank you so much, sir.
Thank you all for giving your valuable time for us. We pay our humble gratitude to Dr. Nilima Gupta and Dr. Naseem Ahmed sir for being with us in our event. So once again, thank you so much. For big round of applause for Dr. Nilima Gupta and Dr. Naseem Ahmed sir.
I would like to request Professor Biyani sir to kindly present the mementos to Professor Naseem Ahmed sir and to Professor Nilima Gupta ma'am. So big round of applause.